Good morning, everyone. Our solution is Transport Monitor, which is a solution for developing road incident management. It is pluggable into 4 roles. Here you can see a citizen reporting an incident and saving it on the IPFS and Filecoin network. So if we can add a particular comment on an incident, and that particular incident can then be dealt by the appropriate police cop who can be directed in a particular manner. So here you can see a particular incident getting stored in the blockchain network. Then we have the incident history, which gives us a log of all the incidents that have been reported, the kind of incidents, their causes, what has led to those incidents, and how they'll be dealt with. We are now switching over from the citizen role to police officer role, where we can see the incident closed, open, in progress, and the citizen and the incidents that have been assigned to a particular police officer. So this particular decentralized autonomous organization is being developed using L2 scaling system, basically METIS. We are now switching over to the dispatcher role, where we can see the live video streaming of a particular incident. We can look at the incident closed, open, and in progress. We can use live peer video streaming, or we can use any other open source streaming as well for doing live video watch of a particular incident. We also can assign a particular officer again for dealing with that incident. This is being managed by a particular dispatcher role. Here you can see the live video streaming operation, which gives us a good comment and a quick comment on what is the reason behind the incident, what are the objects that are leading to a particular incident. We are now switching from the dispatcher role to admin role, where we have 4 key components: sentiment analysis, which gives us an understanding of all the reasoning and all the causation and analytics behind a particular incident. We have developed an analytics tooling, DAO tooling, for managing all these analytic reports and for handling the causation of a particular incident. We also have the health summary, the investigative case management system, and the predictive analytics system for a particular incident. So here we have the officers who are delegated for handling a particular incident. It also looks at the reviews and ratings and comment history for these officers. All these data is retrieved using FEM smart contracts, programmatic smart contracts. It's a newer development that we have done. We also have the incident analysis that we can do in the admin section, which gives us an understanding of the classification of the incident, whether it's a medium, critical, or low type of incident. We can look at the cases per incident type. We can look at the incident area-wise theft analysis. We can also look at what are the areas where the incidents are of higher range and what are the causes of that incident. So this entire set of analytics tooling is being done in a more decentralized autonomous organization manner, and this is possible because of the possibilities that we are able to get from using a blockchain network using Ethereum. So we are now moving over from the analytics section to the reasoning behind the incidents, which is basically cases per incident type. Also the severity and the prediction of those incidents, as you can see below. Incident prediction, which deals with incident rate, severity, resolution, and also the overview surveillance of those incidents, which we can do with a variety of UAV and drone monitors, which are being managed in a decentralized autonomous organization manner. So this is the web version of the project, where we are utilizing a variety of protocols and tools for handling a particular incident. We also have the mobile version of the project, which will be followed next, where we can basically look into how we can use a mobile front end for handling these incidents. We can save the snapshots of the incidents where an alarm has to be triggered. Here you can see the different objects for which we have trained. These are the objects which are basically the likely causes of an incident in certain sections of the road. So we have taken certain cases where we have looked at the CCTV camera footages. We have used open source machine learning library YOLO for doing a variety of object detections in real time as well as in static time. We have looked into specific situations, and accordingly we basically have saved the snapshots where there is a causation of an incident on the IPFS network, and using the Ethereum blockchain and then we basically have been able to retrieve the incident from there. So and you can see a particular set of snapshots getting saved and an alarm getting notified using the push notification system, which is available to deal with incident at a given point of time. This is the alarm snapshot interval that we have. It's customizable, and we can change it according to our requirements. And we can look into the reasoning again, and also trigger alarms so that we can deal with a particular set of events accordingly. The NFT part of it can be minted on Polygon as well as on a certain set of L2 networks. We can also use certain scaling solutions for managing this on a variety of road sections. And we basically have scaled up the entire alarm viewer section along with the DAO tooling analytics solution, which we are demonstrating currently. Thank you so much.